This is a mini lesson for multiplying radical expressions. When we multiply radicals, anything in the radicand gets multiplied with anything else in the radicand, and any coefficient gets multiplied with any coefficient. So in this first problem, I would have 15 as my coefficient, and then 14 times 7, which is 98, in my radicand. I then will need to simplify the square root of 98. So I have the square root of 98 is 49 times 2. So I have 15 times 7 root 2, and 15 times 7 is 105 root 2. And I do have a calculator handy for this. One thing to note is that I may not have ever written that 98 there. If I were thinking through this problem, I would probably think, okay, well, my radicand is going to have 14, which is 2 times 7, times another factor of 7. So I already know where I could skip this step here and skip this step here. I know that I'm going to have a 15 from the 3 and 5, and then I'm going to have a square root of 7 times 7 times 2, so 7 root 2 for the radical part. So you can always use shortcuts like that. In the next problem, I will multiply my coefficients at the start, so I will get 12x to the 10th. And then in my square root, I have 5 times 20, which is 100, and x times x, which is x squared. 100 is a perfect square, and x squared is a perfect square. So I'll write my in-between step, 12x to the 10th times 10x, and that gives me 120x to the 11th as my answer here. In the next problem, I will multiply my coefficients again, so I have 14. And then in the square root, 18 times 6 is not necessarily one you would know. It is 108, and I have x to the 5th times x, which is x to the 6th. But similar to what I was saying before, if I already know that I have the square root of 18 times 6, and I can say, oh, well, 18 is just 3 times 6, then I know that I'm going to have the square root of 3 times 6 times 6, and I could already jump to pulling out a factor of 6, and I could skip this step here that is saying, well, what's the biggest perfect square factor of 108? That's 36 times 3. That may or may not be something that you know off the top of your head, and that's where this method up here gives you an advantage, because you already can write 6 root 3 for that part of it. And then the square root of x to the 6th is x to the 3rd. So I have 6 times 14, which is 84, x to the 3rd, root 3 for this problem. Now, in the examples below, we still have multiplication, but since we see a plus or a minus or a plus and a minus in the parentheses, we know we're going to be distributing. So I have separate terms in the parentheses, and I could choose to simplify those terms at the start, or I could simplify them later. You'll get the same answer either way. The reason I'm going to simplify them at the start is just in case we're able to do any combining ahead of time. So I have 2 root 6 as my coefficient, and then in the parentheses, 6 times the square root of 4 times the square root of 2 minus 5 root 3. All I'm doing here is I'm simplifying the square root of 8. So I have 6 times 2, or 12 root 2 minus 5 root 3. In this case, those still can't be combined, so I'm going to do the distributive property. So I'll multiply the coefficient to the coefficient, and then the radicand to the radicand for this first distributing. So I have 24 times the square root of 12, and then I will distribute the 2 root 6 over here. So I have the coefficient times the coefficient, and the radicand times the radicand. So I'll have minus 10 root 18. Now, you don't need to draw those arrows, or you may choose to just do what you would normally do and kind of go like this and then like this to show that we're distributing to each of these separate terms. I just wanted to show you where I was getting my numbers from. And now I'll simplify. So square root of 12 is root 4 times root 3. Square root of 18 is root 9 times root 2. So I have 48 root 3, because that root 4 turns into a 2. And I have a 30 root 2, because that root 9 turns into a 3. We'll do one more problem. I will again simplify my square root of 12 at the start, I can see that root 3 and root 5 don't simplify. So I have root 6 times 3 root 3 minus 1 times the square root of 5 plus 6 times the square root of 4 times the square root of 3. I'm just going to duplicate that since I can do that in my Notability and simplify this last term here to be 12 root 3. Now I notice that I actually have some like radicals here, so rather than distribute 3 times, I'm going to combine my like terms. So I have the square root of 6 and then 3 root 3 plus 12 root 3 gives me 15 root 3 minus the square root of 5. This makes it so I only need to distribute to 2 terms. So I can write in the coefficients if it helps me to visualize. It's like I have a 1 here and a 1 here. So I will have 15 root 18 when I distribute root 6 to the root 3. And then I will have minus the square root of 30. Square root of 30 will not simplify, but square root of 18 will. So I will do that simplifying right here. And so again, our key ideas for these problems are that we always look for our like radicals, meaning the same number in our square root. If we have the same radicand, then we can add or subtract the coefficients. But that is the only time we can, versus we can multiply radicals no matter what. We multiply the coefficients with the coefficients and the radicands with the radicands.